Says. Okay. All right. A lab technician's given the table below and a sample of one of the three substances listed in the table. They make an aqueous solution. When a conductivity tester is lowered into the solution, the light bulb glows brightly. Ooh, so that means we have an electrolyte. So if something dissolves and is able to light up a bulb, it's able to conduct electricity. Another portion of the sample is placed in a heat-resistant container in an oven and it melts. Okay, identify the substance given to the technician. So if it was good at conducting it and it melted before 450 degrees, so this one's melting point is too high, so it can't be that one. This one doesn't conduct electricity, so we got to be talking about sodium nitrate. So sodium nitrate must be the sample that was given. So again, it mixed with water. It did conduct electricity as an aqueous solution. And when placed in an oven and the temperature was at 450, it melted. So 450 is above the melting point. 307 is this melting point. So sodium nitrate. State evidence that makes it necessary to use more than one property to identify the substance given to the technician. So both of these, both sodium nitrate and potassium chromate. So again, I would write out these whole things. I'm just writing the first initial of these. Both of them are soluble and conduct electricity as an aqueous solution. So it makes them hard to separate until you know this melting point. Explain in terms of ions why an aqueous solution of potassium chromate conducts an electrical current. So if something conducts electricity, it's because it has mobile charged particles. But I don't want to write particles because it says I have to say in terms of ions. So it has mobile charged ions. Those particles that are moving in an aqueous solution are ions. If I had a piece of metal, the mobile charged particles would be electrons, but here I've got an aqueous solution. All right, natural gas and coal are two fuels burned to produce energy. Natural gas consists of approximately 80% methane, 10% ethane, 4% propane, 2% butane, and other components. The burning of coal usually produces sulfur dioxide and sulfur trioxide, which are major air pollutants. Both of them react with water to form acids. Write the general formula for the homologous series that includes components of the natural gases. So methane, ethane, propane, butane are all alkanes. And the formula for an alkane, if you're not sure, you go to table Q. It's CN H2N plus 2, general formula for the homologous series of hydrocarbons. So the answer that is acceptable, CnH2n plus 2. You got to write it just like that. Draw a structural formula for the hydrocarbon that's approximately 2%. So 2% is butane. But tells me 4 carbons. So you go 1, 2, 3, 4. And then it's saturated, which means all of these bonds are going to be hydrogens. There it is. Complete the equation in your answer booklet representing the reaction of sulfur trioxide with water. So sulfur trioxide plus H2O to produce sulfuric acid. So sulfuric acid, the missing reactant and the missing product. I don't have what the actual answer booklet showed, but I can look up what sulfuric acid is. And it is right here, H2SO4. You just look it up on table K. H2SO4. So 2 H's, 2 H's, 1 S, 1 S, 3 and 1 4 O's. So there it is. There's my reaction. And if I just had to find sulfuric acid, you could actually just look it right up on table K like I did. Okay, last page, you guys. State evidence from the table indicating that the proportion of components in a mixture can vary. So up here, a student prepares 2 141-gram mixtures, A and B. Each mixture contains of NH4Cl, sand, and water at 15 degrees. Both mixtures are thoroughly stirred and allowed to stand. The mass of each component used to make the mixtures is below. So state evidence indicating that the proportions in a mixture can vary. hurry. So mixture A has 40 grams of NH4Cl, and B has 10 grams, and I could keep going. Any of these are showing evidence that the amounts aren't the same. So when you mix these three things together, you used a different amount of A and a different amount of this. I couldn't use water because you used the same amount of water, but you could have explained a different amount of this or a different amount of this. Which type of mixture is mixture B? All right, so mixture B has NH4Cl, sand, and water, and it's got a lot of sand. So if you picture it for a minute, the sand's all sitting on the bottom and the liquid's up here. That means it's not very well mixed. So it is a heterogeneous mixture. All right. Determine the temperature at which all of the NH4 in mixture A dissolves to form a saturated solution. So if I have 40 grams in 100 grams of water, I go over here to table G and I find out where that's saturated. What temperature would I need? So here's NH4Cl. I'm going to follow that down to the 40. Here's 40 grams and I go down. That's about 25 degrees Celsius. Describe one property of sand that would enable the student to separate the sand from the other components in the mixture. So sand is insoluble. That is one property. You could also say that sand is very dense. So because it's insoluble, it's not mixing with the water, which means you're going to be able to filter it. Or because it's very dense, it's going to sit at the bottom of the solution. So both of those are ways that you're going to be able to separate it. If it's insoluble, you can just use a filtration. So pour it through filter paper in a flask. Or sometimes when something is really dense, you can actually pour out the liquid and the sand will stay on the bottom. All right, fossil fuels produce air pollution and may eventually be depleted. Scientists are researching ways to use hydrogen as an alternate fuel. A device called an artificial leaf was invented to produce hydrogen and oxygen using sunlight and water. It's an electrochemical cell. Ooh, we're talking redox now. So equations 1 and 2 below represent the reactions taking place. Equation 3 represents a reaction of hydrogen when used as fuel. So state one benefit of using the leaf to produce hydrogen. So it has, scientists are researching ways to use it as an alternate fuel. That's because it has no pollution. Or another one that you could say, so the fossil fuels make pollution. So you would have either, you could say less pollution or no pollution. And another thing you could say is that this one, fossil fuels may eventually be depleted. You could say there's an abundance of hydrogen available. All right, explain in terms of energy why the artificial leaf is an electrolytic cell. So in terms of energy, electrolytic means it requires energy. So you could just write it requires energy. All right, so electrolytic cells are not spontaneous. They need energy to happen. So energy from sunlight needed to have this happen. All right, state the change in oxidation number of oxygen during the reaction represented in equation 3. So here it is at the beginning, so it's a 0. So 0, 2, and then over here, it's a -2. So that's the change in oxidation number. It goes from a 0 to a -2. All right, that was number 85. That was a full Regents exam. That was the January 2016 exam. As we do more and more of these preps and get closer to the exam, there are 2 sessions that I'm not doing practice exams and I'm just answering questions instead. So think about what topics you want to go over. And remember that over here on YouTube, I will be loading this video, but on YouTube, search Nancy Mancuso, you'll see me, and then go to playlists, and then go to chemistry review, and I have all sorts of videos on there. Some of them are literally 5 minutes long. Like if you just need a refresher, ooh, how do you do this? How do you do this? You can go ahead and watch them. All right, good luck, you guys. Let's do this.